Now, if we can go to our packets, and I want to have us go to page 33. Okay, so I want us to do this without the unit circle. Okay, again, this is kind of preparing us for the future. You will obviously get to use your unit circle after you create it, but I want us to see what it feels like without the unit circle, and I want to kind of talk about what we can do to arrive at the answer without having to fill out the entire unit circle. So, but before we do that, let me just do a quick review of, I want to point out a couple of properties and do a quick review before we jump into case 33. Okay, so first is reference angles. Okay, so I want to keep reminding us what reference angles are. Reference angle is where, depending on which quadrant we're in, we can either, if it's degree measure, we can either subtract involving 180 or 360, depending on which quadrant, right? So if you're sitting in the second quadrant and you want to find the reference angle, you find the closest x-axis, which will be 180 degrees, and you just subtract those two values, and that will be your reference angle. Your reference angle is always between 0 and 90. If it's in the third quadrant, you're still going to subtract from 180 because that's the closest x-axis to you. If you're in the fourth quadrant, you're going to subtract involving 360 because that's the closest x-axis to you. Now, with radians, you're going to be involving pi if you're in the second and third quadrant, subtracting from pi or subtracting with pi. And then fourth quadrant, you're subtracting from 2 pi. Now, there's a bit of a shortcut with radians, especially with special right angles. And I want you to look at the pattern here. Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. They all have a reference angle of pi over 6. What is nice about that? Basically, if your denominator is 6, your reference angle is going to be just pi over 6. That's nice and easy to recognize. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. They all have reference angles of pi over 4. That's nice, right? Basically, if you see a special right angle in radian form that has a 4 in the denominator, then you automatically know that reference angle is pi over 4. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. They all have the same reference angle, pi over 3, 60 degrees. Okay, so that's nice. Radians is nice to have that property. Typically, we don't like to do things in radian form, but this is a nice property that will quickly get us to our reference angle. Okay. Now, the second thing is I do want us to do for, even if you're not doing the finger method for your unit circle, that's fine. But I like what the finger method can do for us. It allows us to get to our value without having to create anything. So as a reminder, your second finger, this is your pi over 3 or 60 degrees, right? Middle finger is pi over 4 or 45 degrees. And then your ring finger is pi over 6 or 30 degrees, right? And then if I want to find pi over 3, hold down that finger. My x value is square root of 1 over 2. And then my y value is square root of 3 over 2. If it's pi over 4, then square root of 2 over 2, square root of 2 over 2. And if it's pi over 6 or 30 degrees, it's square root of 3 over 2 and square root of 1 over 2, which is 1/2. That's nice and quick, okay? Now, let's go through this, and I want us to kind of do it with this with this method I'm going through, and just see how it feels, okay? And see if it makes sense, okay? So first, 300 degrees, which quadrant are we in? Quadrant 4, okay. Quadrant 4, what's the reference angle? 60, because you find the nearest x-axis, which is 360 degrees, and fourth quadrant, you're going to involve 360. So 360 minus 300 is 60 degrees. Okay, what are the order pairs in terms of the sign for fourth quadrant? positive, negative, okay? 60 degrees, that's going to be pi over 3. That's going to be my index finger here. So my coordinate is square root of 1 over 2, square root of 3 over 2. Negative carries over my value. And now I'm asking for sine of 300 is sine involving the x or the y. Y. Negative. Okay. All right. 7 pi over 6. Which quadrant are we in here? Greater than 1, right? 7/6 is greater than 1, so we know we're in the third quadrant. This is nice and easy. What's the reference angle? Pi over 6, right? Which is the same thing as 30 degrees. Quadrant 3, my order pair is negative, negative. Okay, finger method, pi over 6, that's my 30 degree. Hold this down, square root of 3 over 2, and 1/2. That's right. Yeah, I'm going to write down the number first, and then I'll carry over the negative. But yes, you're right. So now I'm talking about cosecant. Cosecant is involved with the x or the y. Cosecant is the reciprocal of sine, right? Okay, good. Secant is cosine. So cosecant is sine. Cosecant is related to the negative 1/2. But what do I need to do with that negative 1/2? Flip it. So negative 2. I'm going to do a few more with you, and then I'm going to see if you guys can complete it on your own just by using your fingers and without looking at the unit circle, just to see what it feels like. Okay. All right, 240. Which quadrant? Quadrant 3. Nearest x-axis is 180, right? So what's 240 minus 180? 60. Quadrant 3. Negative, negative. 60 degrees. That's pi over 3, right? 1 square root of 3 over 2. 1/2 3 over 2. Again, negative, negative. All right. Tangent. Tangent, what's the formula for tangent? Y over x, but we have a strategy, right? We want to cover up the denominator so that because we know those will just go away. So y over x will be what? Yep. Negative root 3 divided by negative 1, which is root 3. Let me do 3 more and have you guys do the rest. Pi over 6. Okay, this is easy, right? Quadrant 1. We don't have to worry about any of this. Positive, positive. Pi over 6, that's 30 degrees. Hold down the ring finger, so root 3 over 2, 1/2. All right, secant is related to the cosine, which is the x value. But what do we need to do with the x value? Flip it. Rationalize. Okay, 330, which quadrant? Quadrant 4. Reference angle? Yep, you gotta involve 360, right? Because you're all the way in the fourth quadrant. Quadrant 4, order pair is positive, negative, 30 degrees. Here, root 3 over 2, and with a negative. Okay, cotangent. What's the strategy? What's the formula for cotangent? X over y. So cover up the 2's. What do we get? 3 over negative 1, which is negative root. All right, pi over 2. Pi over 2 is not in the quadrant. So we can say this is in the positive y-axis. Also, no reference angle. Reference angle does not apply for quadrant angles, only for ones that's in a specific quadrant. So pi over 2. Yeah, the sign is there's no sign for the x, but the y is positive. And then the order pair for pi over 2, you're just going up 1 unit from the origin. So that's going to be 0, 1. That's the order pair for pi over 2. All right, secant is related to the cosine. The cosine is the x. And what do you do with the x? Flip it. Okay, so think of 0 as 0 over 1. So if I flip 0 over 1, I get 1 over 0, which is 1 to pi. Okay. So try the rest of the sheets using this method. Don't look at your unit circle. Just find your reference angle. Write down the signs of your order pairs. Use the finger method. Write the order pair down, and then decide what do you want to do with that order pair. Do you need to find the x, the y? Do you need to flip the x, flip the y? Do you need to do y over x or x over y? Once you get the order pair, then you're just looking at the order pair to figure out what your value is. Okay. All right, so try doing it that way. Yeah, you don't have to do this on the test, but I'm just kind of want us to especially move towards this ability to do it without having to always rely on it. A few more minutes, but if you're done with this, see if you can go ahead and try to finish up 37 and page 37 and 38. We'll go over it, but we're just gonna things that you already know, yeah. Page 37 and 38, we're gonna finish that next. Okay, check your answer once you're done. I think it's just nice to know that we can find these values without feeling like we have to fill the unit circle every time.
Last one for the 5 or 4.
Mhm.
Like the cosine, I thought you like flipped it.
You flip it if it's secant. But cosine is the x value. Right, yeah, cosine is the x value, but if it was secant of pi over 4, then I would flip that, make it 2 over 2. Sine is the original x value, and is the original y. Any questions about these? I'll leave this up for another moment. If you guys can, if you're good with this, turn to page 37. We'll continue working. Sorry, no, 36 and 37, so 36 first. We stopped at 19. Anybody still need this? Pretty good. Okay, we're not going to sketch. We're just going to find the reference angle. So if something is not inside our interval, we're going to have to make some adjustments to make it easier to read. So I don't recognize negative 405. So what can I do with that? Yep, add 360, right? Let's get it into a coterminal angle that feels more recognizable. We're still in the negative region. I can keep adding 360. I'll get 315. 315 is in the fourth quadrant. Subtract using 360. Right. Now that we learned the method with those patterns with radian measure, pi over 6, what's our reference angle? Pi over 6, right? I mean, we can subtract from pi, but we were, it's nice to see that pattern, right? Your denominator is 6, you know it's going to be pi over 6. So for 25 through 51, okay, let's go through that method as well. the finger method that we did on the previous page, we're just gonna rely on, what we know about quadrants and order pairs, and from there, okay? So let's gather, quadrant first. Quadrant 3. Dealing with a negative, negative. This is pi over 3 is my reference angle. Pi over 3, index finger, 1. Negative. Cosine is just the x value. Yeah, so my index finger is 60 degrees or pi over 3. Middle finger is pi over 4 or 45 degrees. And the ring finger is pi over 6 or 30 degrees. It kind of lines up with, right, exact, here's the first quadrant. So if I pi over 3, if I hold that down, my x value is 1/2, my y value is √3 over 2. Pi over 4, √2 over 2, √2 over 2. Pi over 6, √3 over 2, and 1/2. I needed to get to a terminal angle that I can recognize, so it's just 30 degrees. Quadrant 1 is tangent is y over x, cover up the denominator, -1 over 33. Let's rationalize that. For the page 37, we may have to do some work getting into a coterminal angle that we can recognize before we do the rest of the steps. Does anybody still need this page? Continue with it. Oh, question. I gotta show you the reasoning. Also, you know, on the footage, you get to use the unit circle. I just want us to get into feeling like we can eventually down the road find this without having to build a unit circle from scratch. Okay, anybody still need this page? Okay. 20. Reference angle, closest x-axis is 180. Degrees. Yeah, go ahead. Secant is related to the x because cosine is the x value. Secant is the reciprocal, so flip that. Okay, 11 pi over 3, is that between 0 and 2 pi? A little bit more than 2. All right, so we have to, so that means it's wrapped around the circle more than once. So what can I do to get into upper range? Yeah, so subtract 2. Right. So that's the same thing as minus 6 over 3 if I want to find common denominators. Okay, so this is in the 4th quadrant. We know that reference angle is pi over 3. Our sine is positive, negative. Pi over 3, 60 degrees, 1, 2. Cosine is the x value. Secant is related to the y value, but I got to flip the reciprocal of sine. Okay, 5,400, that is a large number. We talked about a strategy where if I divide by 360, I can have an idea about how many rotations it is. So it's 15 rotations around the circle. So if I do 360 times 15, exactly 5,400. So that means if I subtract 5,400 minus 5,400, that's really 0. So cosecant of 0, my order pair, that means I'm going to the right. So my order pair is going to be 1, 0, right? Positive x-axis, I move over 1 unit, I don't go up or down. Cosecant is related to sine, reciprocal of sine. What's the reciprocal of 0? Fine, 1 over 0. I'm sorry?
How'd you get the 1 out from?
Okay, so 0 degrees, right? If you think about 0 degrees, 0 degrees is over here. So what's the order pair at this point, right? 1, I move over. Okay, negative 5 pi over 6, that is a negative. It's kind of bled into that division line there. So add 2 pi. Get it into a proper range. Yeah, it's showing negative. It's yeah. there's no separation. It looks like just a division line. We know this is quadrant 3. Sine is negative, negative. Reference angle is pi over 6. That's 30 degrees. Root 3 over 2, 1/2. Negative, negative. Cotangent. Okay, what's our strategy for cotangents? Cover up the 2, x over y. So negative root 3 over negative 1.
It's like cosecant.
Yeah, it's cosecant.
I mean,
It's the reciprocal of sine. So we look at the 0, we gotta flip the 0. So that's why it's 1 over 0, which is on the sine. Okay, a few minutes. I just want to get started 1.16. It's what you already know how to do, but just from a different perspective. So you can bring out your unit circle again. We can refer to it. We'll skip 1 and 2. We've done this already. This is where you plot the order pair, draw your triangle, Pythagorean theorem, and then you do all your trig ratios. Okay, but let's do 3 through 8. Just a little intro into it, and let's talk about. I think this is where something like this is really helpful. So we got to create the quadrant that we talked about. So A, S, B, C. Again, this represents the fact that everything in the first quadrant is positive. Second quadrant, only sine and cosecant are positive. Third quadrant, only tangent and cotangent is positive. Everything else is negative. Fourth quadrant, only cosine and secant are positive. Everything else is negative. Okay. So this is going to be very helpful if we look at number 3 here. So number 3 says, state the quadrants or axis where terminal side of theta is found. So sine is less than 0. So I want sine to be negative, and I want cosine to be negative. Which quadrant will allow both sine and cosine to be negative? Great, right? Only tangent is positive, so that's going to force sine and cosine to be negative. Good. So we say quadrant 3. Tangent is positive and secant is positive. So for secant, I'm just going to put cosine because cosine feels more recognizable. So tangent is positive and cosine is positive. Yes, quadrant 1 is there. I think that's the only one, right? Because we're not going to be able to get these two to both line up to be both be positive. Yep, so just quadrant 1. Wait, say it again. Oh yeah, A means all. Yeah, A means all. All the trig functions are positive in the first quadrant. Okay, number 5. Cosine is positive and cotangent is negative. So whenever I see a reciprocal, I'm going to just put the one that I recognize more, which is tangent. So where is cosine positive and tangent negative? Quadrant 4, because only cosine is positive, which is forcing every other trig function except secant to be negative. Okay, secant is another way of saying cosine. So cosine is negative, but sine is 0. This is not going to be in the quadrant. Sine is 0, so that's the y value, right? So basically, I want something that's negative and 0. Where's the only place where I'm going to have that property? the negative x-axis, right? So because the 180-degree line is negative 1, 0, so that's the only thing that's going to have that property. So I'm going to say negative x-axis. Cosine is equal to 0, so I know my x value is 0. Cosecant is positive, so cosecant is the same thing as sine. Sine is the y value. Basically 0, 1. Where am I going to experience 0, 1? Positive y-axis. Cotangent is less than 0. I like to think in terms of tangents. So where is tangent negative and cosine negative? Quadrant 2, because only sine is positive here, so that's telling us that everything else except for cosecant is negative. So that means cotangent is negative, tangent is negative, cosine is negative. Okay, we're a little ahead, which is fine. Monday, when you guys, I'll send out a reminder this weekend to let you know that we are going to do a unit circle quiz, but when you come in, we'll do a practice run. Make sure everybody feels good, and then we'll do our unit circle quiz. I'm not gonna time it. Yeah. But I'm hoping to get them done with under 10 minutes, but I won't time it. Okay, you get your phone. Yes.